Hello, my name is Jacob and I'll be taking you through parts of topic 2.4 chemical reactions. As you can see, I have highlighted the parts I'll be teaching. This will be exothermic and endothermic reactions in terms of energy profile diagrams and activation energy. Note, all the graphs shown in this video can be found on BBC Bitesize, which is an excellent revision tool. So, on to exothermic and endothermic reactions. Exothermic reactions are reactions that transfer energy to the surroundings. This energy is usually transferred as heat energy, causing the reaction mixture and its surroundings to become hotter. Endothermic reactions are reactions that take in energy from the surroundings. The energy is usually transferred as heat energy as well, causing the surroundings to become colder. Here we can see two examples of an exothermic reaction, a fire and an explosion. Both will be transferring heat to the surroundings. For an endothermic reaction, we can see ice melting and photosynthesis, both of which will be transferring heat from the surroundings to itself. A chemical endothermic reaction can be seen here, where sodium carbonate powder is tipped into a beaker of ethanoic acid, which will make sodium ethanoate, water and carbon dioxide, and cause a drop in temperature on the thermometer, as shown. Next we see an exothermic example. In this example we can see sodium hydroxide solution being poured into a beaker of hydrochloric acid. This is a neutralization reaction which is exothermic and causes a rise in temperature and makes sodium chloride and water. During a chemical reaction, bonds in the reactants are broken and new bonds are made to make the products. Energy is absorbed to break bonds, and thus bond breaking is an endothermic process, and bond making, which releases energy, is an exothermic process. Whether a reaction is an endothermic or exothermic reaction depends on the difference between the energy needed to break bonds and the energy released when new bonds form. During an exothermic reaction, more heat is released when making the bonds for the product than what is taken to break the bonds in the reactants. And the opposite occurs with an endothermic reaction, in which more heat is taken in when the bonds are breaking than what is released when making the bonds. This causes a difference of energy levels between the reactants and products and is called enthalpy change, or delta H. Therefore, from the equation above, we can see endothermic reactions will have a positive delta H and exothermic reactions will have a negative delta H. This can be shown more clearly on an energy profile diagram. Energy profile diagrams show the level of energy of reactants and products. The bigger the difference between the energy of the reactants and the energy of the products, the more energy is given out or in. So, for an exothermic reaction, we can see energy is released as heat, and first the products will have a lower energy level than the reactants. And for an endothermic reaction, we know that energy has been absorbed as heat, and therefore the products will have more energy than the reactants. The activation energy is the minimum amount of energy required for a reaction to take place. This could be represented on an energy profile as a hump. This shows how much energy is needed for the reactants to react and become products, and can be seen here on this exothermic and endothermic energy profile diagram. Another way of describing activation energy is the energy required for two reactants to collide and have a successful collision. This will be explained more thoroughly in another topic called rate of reactions. Note, another way of saying activation energy is by EA. And that's it for me. Thank you for listening, and I hope you enjoyed.